Logistic regression and the ROC curve. It's time to introduce another model, logistic regression, and logistic regression for binary classification. Despite its name, logistic regression is used for classification. This model calculates the probability P that an observation belongs to a binary class. Using our diabetes dataset as an example, if P is more than or equal to 0.5, we label the data as 1, representing a prediction that an individual is more likely to have diabetes. If P is less than 0.5, we label it 0 to represent that they are more likely to not have diabetes. So, linear decision boundary. Note that logistic regression produces a linear decision boundary. As we can see in this image, logistic regression in Scikit-Learn, using logistic regression in Scikit-Learn follows the same approach as used for another model. We first import logistic regression from sklearn.linear_model. Next, we initiate the classifier, split our data, fit the model on our training data, and predict on our test set. In this video, we use the char dataset. Predicting probabilities. We can predict probabilities of each instance belonging to a class by calling logistic regressions predict_prob method and passing the test features. This returns a two-dimensional array with probabilities for both classes. In this case, that the individual did not churn or did churn, respectively. We slice the second column representing the positive class probabilities and store the results as y_pred_probs. Here we see the model predicts a probability of 0.089 that the first observation has churned. Probability thresholds. The default probability threshold for logistic regression is in Scikit-Learn is 0.5. This threshold can also apply to other models such as KNN. So what happens as we vary this threshold? The ROC curve, we can use a receiver operating characteristic, in short, ROC curve, to visualize how different thresholds affect true positive and false negative rates. Here the dotted line represents a chance model, which randomly guesses labels. When the threshold equals to 0, the model predicts 1 for all observations, meaning it will correctly predict all positive values and incorrectly predicts all negative values. If threshold equals 1, the model predicts 0 for all data, which means that both true and false positive rates are 0. If we vary the threshold, we get a series of different false positive and true positive rates. A line plot of the threshold helps to visualize the trend. Plotting the ROC curve, the plotting the ROC curve, we import ROC underscore curve from sklearn.matrix. We then call the function ROC underscore curve. We pass the test labels as the first argument and the predictive probabilities as the second. We unpack the threshold. We unpack the results into three variables: false positive rate, FPR, true positive rate, TPR, and the thresholds. We can then plot the dotted line from 0 to 1 along with the FPR and TPR to produce a figure such as this. This looks great, but how do we quantify the model's performance based on this plot? We had a model with one of the true positive rate and 0 for false positive rate. This would be the perfect model. Therefore, to calculate the area under the ROC curve, a metric known as AUC scores range from 0 to 1. With 1 being ideal, here the model scores 0.67, which is only 34% better than a model making random guesses. Let's practice. So here, so I'm going to the, to this here, we can calculate the AOC in sklearn by importing ROC underscore AUC underscore score from sklearn matrix. We call our ROC underscore AUC underscore score, passing out test labels and our predicted probabilities calculated by using the model's predict underscore prob method on X underscore test. As expected, we get a score of 0.67, and let's practice. Let's build a logistic regression model and evaluate the performance. So for that, I'm taking the Chan data. We already imported earlier examples. So again, I'm taking the head end info, and then here I'm taking the Chan as the, if you see this data, the Chan is the 0, 1, 0 and 1, that is a Y. So remaining are features. So here X, from the X I'm removing the drop in the Chan. Then what are the X is there, that is the features, and this is a target variable. Then this is the shape. Then I ran this logistic regression. If you see this, I passed then where the so first of all we need to run this code. Then run this code. So we got 0.21 as first variable. Then when I curve this thing, this is the ROC curve. So when we ran this ROC AUC matrix, you see the 0.82 is the correct threshold. So this is the good accuracy for us. And when I ran this thing, this is confusion matrix, and this is the precision and recall. So that's where 82 is the where we got the accuracy. That is about this using logistic regression. I'm stopping here. We will connect with another concept. Thank you. Bye bye.